Okay, so for this one, they're wanting us to find, it says find the measure of x in the figure. So what is x? X is that longest distance in this box. So imagine like if you have this box, suppose you have a trunk like this or a chest in your bedroom, and you want to put some long thing, a baton or a baseball bat or whatever, some kind of long straight thing like that, and you're wondering what's the longest bat, longest baton, or something else I can put in this chest, in this box that I have in my bedroom. Well, the longest dimension is right there, isn't it? From corner to corner. That's going to be the longest dimension in the box. So we'd like to find out what is that length. Well, to find that length, this length right here, we got to set up a right triangle. We can make a right triangle right there, then we can use the Pythagorean theorem, a squared plus b squared is c squared. So there we have a right triangle kind of sitting in the middle of the box with this right angle right here, and x is going to be the c, it's going to be the side across from the right angle, but we have a problem. We know this is 12, this side is 12. We know this is x, that's what we're trying to find, but we don't know this side down here. You see the problem? If we start to go straight after that triangle sitting in the middle of the box, we're going to run into trouble because we don't know two of the sides, right? We don't know the x, which of course we're trying to find that, but we don't know that diagonal down on the bottom of the box either. You can't solve an equation with two letters, right? You can only have one letter, the rest have to be numbers. So I can't start with that triangle. I cannot start with that triangle. First, I have to find this D, the diagonal on the bottom of the box. So that's where you start. You've got to first find this right here, which is the diagonal on the bottom of the box. And you can do that using this right triangle that's on the bottom of the box. Once you work with that right triangle and find D, the diagonal on the bottom of the box, then you can shift and go and do a second triangle, which will have the x in it, and we can find x. So it's going to be a two-phase problem. First, we got to find D. Doing this, so we're going to do the Pythagorean theorem twice. So first, find D, the diagonal on the bottom of the box, or it's technically a prism. So let's start with that. We got to find D, the diagonal on the bottom of the box. So right here. So there's the little triangle sitting on the bottom of the box. Here's the right angle right there. And D, notice, is the side across from the right angle. So when I write a squared plus b squared is c squared, which is the Pythagorean theorem we can use anytime we have a right triangle. The c is the D, right? Over here, this side right here, that's the longest side in the right triangle, which is always the C. So you always get, whenever you use Pythagorean theorem, you've got to identify the C first, find out which side is the longest side. That's called the hypotenuse. That's the side across from the right angle. And in this case, we're calling that D for diagonal. The other two sides, this is the A and this is the B, or you could switch those around, it doesn't matter. So 16 squared plus 12 squared is D squared. All right, let's use our calculator. So 256 plus 144 is D squared. And then I'm getting 400 is D squared. And then root it. And so D came out a nice clean 20 for me. So D came out 20. So I've got D now. I've got the diagonal, which is on the ground. The diagonal on the bottom of the box is 20. So now that I've done that, now second phase. So first find D, second find X, the diagonal, which is also a diagonal in the middle of the box. So second, find x, which is the diagonal in the middle of the box. So let's do it. Let's come on up here and try to make this really clear here. That right there. So here's the triangle I'm looking at now. I'm looking at that triangle through the middle of the box, right? And I'm trying to find D. No, not D. I already got D. D is 20. So right here, this side, let me be more clear here. This side is 20, right? Found it right here. D is 20. This side is 12. And this side is x. And see the right angle right here? There's the right angle. Which side is the hypotenuse? The longest side, the side across from the right angle, there it is. So I'm gonna write that formula yet again. It's gonna be a squared plus b squared is c squared. We're using the Pythagorean theorem the second time here. Okay, so then it's going to be, which one is the c? You always have to identify the c first off. Which one is the c? Well, it's the x in this case, right? This is our c because it's the longest side. The longest side, the side across from the right angle, here's the right angle. The side across from the right angle is the longest side is the c. The other two are shorter. They add up squared to equal the bigger side squared. So what are the other two? The other two are 20 and 12 in my case. So that's what, 400, 144, x squared. So add those up on your calculator. 544 is x squared. And the last step to finish solving for x there is we got to square root it, because that turns it into regular x, doesn't it? Then just hit the buttons on your calculator. I'm getting 23.3238. I'll say 323. And it says round to the nearest hundredth up there. So two places, two decimal places. So I'm going to go, okay, cut it right there, two places. So this is a 3. If it was 5 or more, I'd round up. So I just leave it 23.32. So that's my answer, 23.32. And then you choose the units. In this case, it's meters. Mine are meters. You might have a different kind of unit, 23.32 meters. So there we go. We were able to find x, the longest side in a box. That's interesting. The longest dimension in a box, but we had to do it in two phases. We had to first find the diagonal on the ground using the Pythagorean theorem for the ground. A squared plus b squared is c squared. And then we found the ground, the d, was 20. And then we did a second right triangle through the middle of the box using the 20, the 12, and then x. And so we did Pythagorean theorem again and found the diagonal through the middle of the box. There we go.